Conduction, Heat Transfer Methods in Sustainable Building Design. Welcome to Building Knowledge 101. In this video, we examine the fundamentals of heat transfer in buildings with a focus on conduction. So let's start talking about energy efficiency, and let's talk about heat transfer, because that's the main goal here, is reduction of heat transfer. Many sustainability programs encourage greater use of natural lighting and expanded views. We know the benefit of giving people within a hospital, an office building, a school, an uninterrupted view to the exterior. We know that connection is a very strong, healthy building. We also want to utilize more natural light as opposed to artificial. So glass and glazing is being utilized more and more as a substantial percentage of the building envelope. For that reason, it's critical to effectively evaluate their contribution to the energy performance of the project. From a design perspective, it is important to understand that in colder climates, the building is losing heat through the exterior wall. And in warmer climates, the building is gaining heat through the exterior wall. This process is called heat transfer. That's heat moving from one area to another, heat transfer. So heat transfer occurs in three ways: through conduction, convection, or radiation. So let's start out by discussing what conduction is. Conduction is a transfer of temperature from hot to cold through a solid material via molecular interaction within the solid material. Temperature is always going to move from hot to cold. Because aluminum is very conductive, framing systems without deliberate attention to heat transfer are susceptible to substantial heat transfer due to conduction. Again, this is a concern for the design team. They need to have a strategy to restrict heat transfer through conduction. On the left here is a non-thermal frame, and when tested in accordance with AMA 507 with an insulated glass unit that has a center glass U factor of 0.28, this will allow heat transfer to still occur through the frame, but the system has a system U factor of 0.47. Now, your design team wants to improve the performance of that, so they have a couple of different options they can look at. One of the ways that they can improve it is, first of all, looking at the glass unit they're using. So this glass unit has a center glass U factor of 0.28. Our first change is going to be to improve the glass and use an insulated glass unit with a center glass U factor of 0.20. This will yield a 15% improvement, taking us down to a system U factor of 0.41. Now that surpasses the baseline performance requirements in both zone 3 and 5. But because it's a non-thermal frame, it's still susceptible to condensation on the interior of the frames and to heat transfer through the aluminum to the exterior. So the third model here is a thermally broken framing system, and it has the same glass, 0.20 center glass U factor, and that gives us a system U factor of 0.30, which is a 23% improvement over the original design. So you can see by making these simple changes, we've incrementally improved the performance of our glass and framing system. So you have your baseline model, you start looking at what tools are available to you to start incrementally improving performance. And as you improve that performance, we're looking at 23% improvement here. In your sustainable rating systems, that will begin to award you points for improving energy performance. That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.